This is January 2012 AS2 and we're going to be looking at question 13e. This is an empirical formula question and we have been given the percentage by mass of carbon, hydrogen and bromine in this molecule. And so how we do this is we need to first of all work out the ratio by the number of moles. And so we write this out as carbon to hydrogen to bromine. Now when you're given the percentages, you can take them to equal the mass of that element in the substance. So you're essentially saying that you have 100 grams of the substance, and so for 100 grams you're going to have 26.3 grams of that is going to be carbon. So first of all, you start with the mass. So we have 26.3 grams of carbon, 3.5 grams of hydrogen and 70.2 grams of bromine. So we need to then work out the number of moles. We do that by using N equals mass over RFM. Okay, so for carbon that's going to be 26.3 over 12. For hydrogen that's going to be 3.5 over 1. Now notice we just do it over the relative atomic mass of hydrogen and not of the molecule of hydrogen, which would be H2. We don't use that because it's hydrogen as part of the isoprene molecule, and so you may only have one hydrogen atom in that. It's not hydrogen as the diatomic molecule itself. So our number of moles of bromine is going to be 70.2 over 80, as that's the relative atomic mass of bromine. So put those into your calculator and you should get that you have roughly 2.19 moles of carbon, 3.5 moles of hydrogen and 0.8775 moles of bromine. Now at this stage, to get your ratio into whole numbers, you divide through by the smallest number of moles. So again, divide through by the smallest number of moles, and in this case that is bromine at 0.8775 moles. So divide each of those numbers by 0.8775 and you should get that you have 2.5 moles of carbon, 3.98 moles of hydrogen, which is roughly 4, and 1 mole of bromine. Now you can see that they're still not in whole numbers, and think to yourself, how could I get this into whole numbers? And the only decimal we have is 2.5, and to get that into a whole number we would need to multiply by 2 because it's 2.5 essentially. So we need to not only multiply that by 2 but everything else, and so we get 5 to 8 to 2. So that means our formula is going to be C5H8Br2. And that's the empirical formula that you find out. If you're asked for the molecular formula, there's another step. But for empirical formula, that's the only steps you need to take. So take your percentages to equal the mass of that element in the formula, or in the compound. Work out your number of moles by dividing by the relative atomic mass, ignoring whether or not it's diatomic. Then divide through by the smallest number of moles to get it to attempt to get it into whole numbers, and if it's still not in whole numbers, then multiplying them all by a number that will get them into whole numbers. So for example, if you end up with, in this case we ended up with 2.5, you would times by 2. If you ended up with something like 2.33, you would need to multiply by 3, and that would get into a whole number. Or the same, similarly, if you got something like 2.666, again, times it by 3, because that's essentially saying it was 2 2/3. So multiplying it by 3 will get it into whole numbers.